Okay, so what we're going to be working on right now, practice, is how to find the rule, how to write a rule to describe each transformation. So some cases we have rules, but some cases when I give you guys a graph, sometimes it's just easy to tell. Now I can tell the image is not bigger or smaller, so I know it's not dilation. I can tell it did not flip or anything, so it's not reflection nor rotation. I can easily tell that it went down three spaces. That's all it did. The same image, it just went down three spaces. We know that we start on the black and we finish with the blue because the letters on the black are just plain letters, Q, R, and P. Now in blue, each of my letters has the little apostrophe, which I call prime. You cannot tell the prime on the Q because it's right on P, but we have Q prime, R prime, P prime. So that's how we know we start with the black and we finish with the blue. Now I said we notice that it just went down. When you move sideways, up or down, that is translation. So first of all, let me identify the transformation by calling it translation. When I mean identify, I want you guys to tell me whether it is translation, reflection, rotation, dilation. So I identify, I can tell it is translation. Now let me write the rule for it. What happened here it is I know it did not move sideways. So I'm gonna open my parentheses and I'm gonna leave the X alone. Right? It did not move sideways. The only thing is it went down three spaces. So I'm gonna write Y minus 3. I did write in my X, I didn't write X plus 0 or X minus 0. I just wrote X. It did not move sideways, so leave the X alone. Now looking at question number 12. The interesting part of number 12 is I can tell this is translation as well. So let me identify, I'm going to say translation. And if I follow each of my points, so any of my points, as a matter of fact, I should follow all of them. I notice that I go to the right. I go to the right 5 spaces and I go up 1. So the way I'm going to identify 5 to the right, I'm going to write X plus 5. Right? I would have said minus if we would have gone to the left. So X plus 5 means 5 to the right, and Y plus 1 means 1 up. Once again, I know I start with the black because the letters in black are just regular letters. And I know I finish with the blue because each of my letters in the blue have the little apostrophe. S prime, R prime, T prime. Now in classroom, I went over a few rules. Why did we have reflection? So that's something for the classroom. I talk about a little easy way how to tell reflection when it comes to the graphs. Now for 13 through 16, I don't have a graph. So I'm going to have to rely on the formulas if possible. Now, looking at E and E prime, I see that my numbers totally changed. Like I see a 5 in E, but I don't see a 5 in E prime. Right? I can tell my values totally change. Usually that happens in translation or dilation. Unless some special cases, it might happen on reflection or rotation, but usually this happens on translation or dilation when the numbers totally change. Let me try translation. I look at my X value. Once again, I'm looking at E, my point's E. I see my X value is -5, and then I ask myself, I can only add or subtract. What can I do to -5 to make it -1? I can only add or subtract. So in order for -5 to become -1, I will say, well, I need to add 4. Right? -5 plus 4 is -1. Let me make sure it works for all of my X values. If it does, then I'm looking at it, I'm on the right track for translation. I notice that it does work for all of them. So X value, I'm going to say add 4. Now let me think of my Y value. I'm looking at my Y values on E. My Y value to begin with is -4, and I wanted to make it 1. Right? I want to follow my Y value. Once again, I can only add or subtract. So I'm thinking, what can I do to -4 to make it +1? In this case, I will have to say I'm going to add 5. Let me make sure it works for all of my y values. In this case, it does. So that's how I know it is translation. So the rule for this, I'm going to write translation. I'm going to identify this as translation. And then I said on the x value, I went x plus 4. On the y values, I went y plus 5. And that's all I'm going to do. Now let's take a look at number 14. I see w here and w prime way over here. That usually gives me a hint it is reflection. Now reflection, usually my values don't change, right? I have special cases on the formulas, and usually my values don't change. So if I see a 4 in w, I should see a 4 in w prime. Usually that's what happens. Now for these notes, I wanted to include hard questions, right? It's lecture, so it's okay if I include really hard questions. On homework and quizzes and tests, I try to not include these, but I'm going to include these on the lecture. Now, on reflection, I noticed that my y value did not change. Once again, I know I'm dealing with reflection because g is on the far left and g prime is on the far right. Now, let me write to begin with reflection across. Now, I take a quick look at all my points and I notice that neither of my y values, once again, I'm checking the y values of v, u, and t. I notice that neither of those change the sign, so I'm on the right track. Now, when it comes to the x value, I'm thinking there's -4 and there's a 2. I want to know which number it's right in the middle, which number is right in between -4 and 2. Use a number line to identify it if possible. If not, just do the average. The average, I'm going to add the two numbers, right? At -4 plus 2. I'm going to add the two numbers and divide it by 2. I'm going to get the average is -1. I could have easily identified on t, right? There's a 0 and a -2. When I ask myself what number is right in between them, -1. So the value that changed was x, and the number that is right in between them is -1. So I'm going to write x equals -1. If the value that was changing was y, I would have said y equals. But here, since the value that changed was the x value, I said x equals, and in this case, -1. All right, let's take a look at number 15. Have some decimals, so that's a big hint. This is dilation. I'm dealing with dilation. So let me see if it's dilation. Let me start writing dilation of. Now I must find my scale factor. It doesn't matter which point I use and which value, whether x or y value. So in this case, let me use my point v, and I'm going to use the x value. And I'm going to divide my numbers, starting with the number from the prime. So here I'm looking at 5 divided by 2. Starting from the number from the prime, 5 divided by 2. It is 2.5. I quickly take a look at all my numbers. It seems like I did multiply by 2.5. All my numbers I multiplied by 2.5. I quickly take a look. Yep. That's how I know it is dilation. Dilation of 2.5. So, matter of fact, if I was to graph these, the original number, the original figure is smaller than the one after the dilation. I know that the second image gets bigger because my scale factor is more than 1, right? 2.5 this case. Now let's take a look at number 16. I have b on the far left and b prime on the far right, and I said usually that happens on reflection. Now, on reflection, I noticed that my x value here did not switch. I quickly take a look at my C's, my D's, and my E's, and I noticed that neither of my x value switches. So I'm on the right track. The only one that changed was the y value. I'm looking at one of my numbers is 0 and the other number is 2. because I'm following B. I notice that one of my values is 0 and the other one is 2. I ask myself, which one is right in between them? 1. So, okay, so I know this is reflection, so I'm going to write reflection across. The one value that switched is the y value, so I'm just going to write y equals. And then I said the number between 0 and 2, the number that right in between them is 1. I quickly take a look. Between 3 and negative 1, yeah, the number right in between it is 1. Yep, the one right in between is 1. The number between 1 and 1, yeah, it is 1. So it worked all the way across. So I know it is for sure reflection across y equals 1.